Okay. All right, just as long as someone, I'm assuming people can hear me now. Someone just says like hands up on the chat or whatever. Then good. Thank you. All right, good. Welcome to the database course, DV202. I'm your humble host, Michael Minak, and I think just to introduce class here. Class, where are you? Are you? Maybe you can show your, just so people can see what you look like. Maybe just briefly share your camera if you're there. Class is the assistant for the course, so class would be doing the labs, and then would be doing some of the recitations, and I'll explain all this in a bit here. So if anybody has any immediate questions, or any questions at any time, you can always either just speak them out or put them in the chat. So let's just see here. So if I see a chat come up, then I'll, here's one. Okay, good. Oh, that was something else. All right. Yeah, so welcome to the database course. When class gets here, or when let's see here. Is he here?
I am here.
Oh, good, good, very good, very good. So that's class. So the assistant, or amanuense.
Yeah. Can you hear me at all, Michael?
I can hear you. Yeah, I'm assuming they can.
All right. Yeah. Okay.
Yeah.
Yeah. I assume so as well. Well, I'm Klaus. I assume that most of you have seen me on some other course. Basically, I don't have much to say. Michael seemed to have made a pretty good introduction, but basically on the camera page, when you can access it, I guess camera is down for you as well.
Oh.
Perhaps it's down for me at least. Yeah, basically all the UMU services seems to be kind of down today, but still, there should be, if there isn't already, but if there isn't, I will update it. There will be a link to a Git repository, which will contain all the labs. It currently contains the deadlines for the labs, and it contains a introductory, like, set up your database lab kind of thing. It's not something you have to do. Well, you have to do it to complete other labs, but you can do it if you'd like. If it isn't automatic, you might have to contact support to get an SQL database. I can look into that.
Yeah.
And there is a Riot room or element room, which should be linked from the page as well, which you can enter. And you can, if you have any questions on the labs, there will be like normal tutoring or lab times. They are in TimeEdit when you can access that as well. We'll do it through tutor queue, which I hope, or most of you will have seen, but there will be some instructions on the page as well for that. You can always send an email to me, or preferably contact me on Element, so chat.cs.umu.se. There will be a link to that as well. And there is a public like database course room, which would be even better if you were to ask your questions there, because if I answer them, then other people can see the answers, if the question seems to be relevant for other people as well.
Yeah.
Yeah, but that's basically it.
Sounds good.
Have a nice lecture.
Yeah. It'll be nice. Okay, thanks you, class.
It will be nice.
Thanks for showing up. And then, so everybody knows who class is now, and that's the assistant. So luckily for me, it still is working. That is Cambro. So I'm going to show you guys what Cambro looks like here. And I guess I'll just share my screen.
I'll leave.
Here we are. Okay, there we are. All right, so I'm assuming everybody can see this. This is, I'm sharing the screen, right? So get that on. Good. Again, any questions you have, maybe just type them in chat, or yeah, type them in chat probably is the best. Okay, that right there is the we'll get to that in a second here. But anyways, this is the Cambro site. Oh, please, I hope it works. If it doesn't work, this will be bad. Huh. I think the problem is that I have to go back here. Cambro is a little bit tricky. Overview. Good. All right. Very good. Okay. So I'm assuming that well, based on what Klaas said, is that not everybody can see this yet. Is that true? Is anybody not able to access Cambro? Because it might be good for you guys to kind of follow along with this, so that you can kind of click around yourself, so you can get used to it. Because we're going to do everything from Cambro. So I can see it. Good. I am. So all right. So you guys can get into Cambro yourself. Yeah, I guess, I mean, they're getting the problems resolved as we speak, I suppose. Anyways, okay, so I'm assuming you guys can see this right here. So this is the main site, and now I've taken away the banner, so it's kind of official. Okay, so first of all, okay, so welcome to 5DV202, Introduction to Database Management. Okay, so the overall aim of this course is to equip you with the skills to model and implement database solutions. All right, so that's that hopefully will come in handy in your careers and stuff. So the book that that we use, and it's basically here. Let me just show you guys the book here. I'll live dangerous here, and then go back to stop the share, and then show you guys can see this, right? This this book it's a little bit old now, but it's still a pretty solid book. So I'm not sure. I mean, how many people have actually bought the book or have a physical copy yet of the book? Let's see here, chat. Has anybody gotten the book yet? Okay. Yeah, you can see it. Good, you can see it. Yeah, so this is a little bit of an older copy. This is like the second edition, but the third edition is essentially has the same table of contents. And so then I should say this also is that there is, I mean, you're not supposed to, I think it's on Google Books or PDF out there. I mean, I don't know. Anyways, but it's a good book. It's a solid book. It was the book used in the Stanford course. So I've been playing with the idea of changing to a more modern book, but I'm not really sure. This book seems to be good enough, and I will supplement with more modern stuff. I'll supplement that with extra readings as we go along. Okay, so that was the book. I just wanted to show you guys the book. Go back to the screen share. Okay, come on, Zoom. Zoom takes a while to do the share. Okay, now we're back to this. Okay, so here we are with the Cambro site here. Okay, so that was the book. And then I'll be putting additional materials out as well. Okay, so the lecture consists of 10 lectures. I'm sorry, the course consists of 10 lectures. And they're all, thankfully, if we go down here to time edit, they're all in a fairly consistent pattern. So by the way, I'll talk about this in a second. We're going to get rid of this. So there's not going to be any handleiding this week. But basically, we have Mondays and Thursdays from 10 to 12. So the lectures are going to be, of course, held on Zoom because of the pandemic. And so we're going to be using this the same idea. It looks like so many people got onto this, so that won't be a problem for you guys to get onto Zoom. All right. So there's going to be 10 lectures. And then if you click on that lectures there, then you get, these are kind of the initial readings I have assigned, but these are subject to change. And I might add in some extra materials. Now these readings, the thing is to remember about these readings is I do expect for you to actually read them. So you are responsible for basically everything in these page limits or these section limits inside the textbook. And then anything else I put on here. When you take, I'll talk about the exam in a second, but basically the exam, because it's COVID times, has to be done on Cambro. So so it's going to have to be open book because I can't sit there and police whether or not you have the access to the book. So actually, in this case, the demands are going to be fairly high that you've read it. All right. So I really would suggest that people do the readings It's again, like I said, it's a pretty good book, and there's not that many readings. So, and it's fairly dense. It's fairly concise. It's not there's not too much. Yeah, it's worth the time. All right. So basically, the course consists of these 10 lectures, and in fact, there are 11 lectures, but I'm only showing 10 here because we're going to have a catch-up lecture here. We're going to have I'm calling it 5.5, where we're going to catch up if we get behind. The slides, those are subject to update as well, but you can click the slides here. So I'm keeping the slides up from last year, but I'll make some minor modifications, maybe actually add some stuff in. All right. So this may be new to you guys. I'm not sure how many people have had recitations before, this notion of a recitation. But the way recitations work is that you're going to have 4 different recitations in this course, and they're each worth 50 points, but I'll get into the points later. Basically, when these get released, they are a set of problems, and what you as students do is you basically do these problems. You work them out, and then you can just like write them down and scan them later, but in one way or another, you upload these to the Dropbox, and I guess if I go to student view here, actually I should do the whole thing as a student. You have a Dropbox here. So in this Dropbox, you're able to, there I am. You can actually go in and drop in your recitation work. So you're expected to do that with recitations. And then the way it works is the following. That is that then I send out, before we actually hold the recitation, and here are the times right here. You'll see the times of the recitations. And these are times of when normally lecture is held. That before I send these out, what I'm going to do is I'm going to ask for you to claim which of the problems in the recitation. So there'll be a link here to the actual problems. You're going to have to say, yes, I can do it, or no, I can't. All right. So basically, you're just going to fill out a survey that says which of the problems you claim you can do. All right. So once you do that, then once we actually hold the recitation, and these will be on Zoom, and at these times, you can either go to Michael's room or you can go to Klaas's room. What we do is we basically look at the claim, and the claims are for Michael or for Klaas. We look at the claims and we randomly pick people to present the solutions. Okay? So the idea behind this is that people will do the work and they'll think it through beforehand, because it's so embarrassing to be completely unprepared. Also, another thing to know about recitations is you don't have to get the problem right, but you have to be able to kind of at least, you have to have tried it. You have to have some kind of opinion, or at least some kind of work to present, all right? So that's the basic way recitations work. So the idea then is that maybe you would claim I can do all these problems because you can do all these problems, and then as it turns out, you don't get called on, all right? You don't get called on at all. Well, you still get the points, right? Because you took the risk to say you could do them, all right? So I hope that makes sense to people. If there are any questions, just type them in the chat. So that's how recitation works. So there's a little bit more to say about that, and that is that, okay, so you basically, again, you do the problems, or you kind of work it on your own. You can work it in groups too. That's fine. I mean, because when you get called on, you're going to be an individual. Then you put them into, you load them into Dropbox. You upload them rather, and then you might be asked to present them, like I said. So you're going to fill out the claim list on Cambro, and then these claims you'll be randomly selected. I'm repeating here. All right, so you're going to get 50 points per recitation, depending on which problems you claim you could solve. Okay, so if you only claim that you can, if there's like 10 problems, you can only do like 7 of them, then what's that going to be? That's going to be 35 points. Oh. Okay, where can we find the list? There was a question here. That's on I'll show you where you find the actual readings. The readings are here. If you go back here and you go to lectures here, if you look in here, it says, it'll give you the section numbers, right? So those are the readings as of now. I might add some more. These are the ones that you will be responsible for. Okay. All right. So, well, back to recitations here. All right. So at the end of the course, there's going to be one final recitation session, and there you can make up any recitation you didn't fully complete before. But when you make it up, you have to claim all the problems. So you got to get 100% of the problems on the recitation claim. And you can only make up one, all right? So this actually makes a little more sense when we used to have physical meetings before COVID. But I just kept it around. So the idea here is that if you can't, if you couldn't make it to one of the recitations, but of course we can all make it to recitations now because we have Zoom. Right? But if you have maybe something else going on at that time, you can miss one of the recitations and then make it up later. But only one of them. And when you make it up, you have to do the whole thing. All right. I hope that's clear. If anybody has any questions, just type them. Okay. All right, so that's recitation. And then, of course, there will be an exam, and it will be on Cambro. And I have some of the earlier exams here. Actually, it's funny, because COVID was really starting at exam time last year, I have, last year I did do a Cambro exam for the database course, and also the re-exam. So I'll post those up here as well, so you can see what it kind of looks like when it's done over Cambro. All right. All right. So that's one thing that, the lectures, the recitations, and the exam. That's kind of the theory side of things. Now, as Klaus had mentioned earlier, that there's going to be some labs. All right, some lab assignments. So if you click here, so you can click right here, and you get kind of like, this won't change. This is kind of a description of what the problems are going to be, what the lab problems are going to be, basically. But what's more important, what gives you the actual, the way you do the labs and the way you, really look at them right here, is this lab section right here. And that's what Klaus was talking about before. So if you click on that, that'll take you to this GitHub, and then he's got this is, where he manages that. All right. Yeah, so that's that. Let's see here. What else? All right. Okay, labs. All right, this is just saying that because of the pandemic, we're doing everything in distance. This means Zoom for the lectures, recitation, and lab reviews, and Cambro for the exam. Okay, these lectures are going to be recorded. They are being recorded. In fact, this one right here is being recorded, the last I saw. And these recordings, at the end, when I generate the recording, what I'm going to do is I'm going to paste it onto the lectures site here, or page. So right here, there's going to be a link to the actual video. Okay, and the videos, I'm going to put them on YouTube, and I'm going to make them so that they're not listed. So no one, you don't, if you ask a question, your voice is not going to be broadcast over the whole internet, without control. It'll just be those people who have a link to it. Right? Okay. The recitations, however, will not be recorded on Zoom. We're not going to do that. So, all right. Another course teacher. No. So there's a question here about whether I'm going to, after 15 days, I will remove. There's some. No, I'm just going to pretend like I didn't see that. Sorry. I'm just going to leave them up there. But after the course is done, I guess technically we'll have to see. If it has your names on it, it's kind of maybe sensitive. But the thing is, again, I'm not going to publish it just as an open thing that can be searched by anybody. It's going to be, the links are basically, once you get the links, and the links, again, will be right here. So this will be pretty much the only link to it on the whole internet. Yeah, okay, keep quiet, good. Yeah. Yeah, anyways, it doesn't seem, I'm sure it'll be fine. And if it isn't, we'll cross that bridge when we come to it. Right. Lectures has to have captions. Yeah, okay. So, well, I don't know. Maybe YouTube will make the captions automatically or something. But based on that, I need to enunciate all my, everything perfectly. Okay, so where are we now? We're at the grading policy, I believe. So, well, maybe a little bit more here. Okay, först och främst, jag kan svenska. Jag glömde att säga det. Jag kunde ha gjort det. Vanligtvis, det första grejen jag gör när jag undervisar, jag börjar med i svenska och jag frågar studenter, vill du att jag fortsätter i svenska eller engelska? Och alla säger engelska, snälla, gör det i engelska. Men jag förstår svenska. Så om du vill fråga mig någonting på svenska eller skriva någonting på svenska, det är helt okej. All right. So the people who don't speak Swedish, I just said that, well, I can speak Swedish. I can understand Swedish. I can't write Swedish very well, though. I'm very bad at that, actually. My spelling is terrible in Swedish. But we're going to be in English. I'm going to present in English, and the materials are going to be in English. So that's that. But when you present either your lab reports or the recitations, you can do it in Swedish. All right, so it's your right. Okay, let's go to the grading policy. Let's get this done. All right, so there's the two parts, two moments, I guess what they call them, to the course. The first one is the principles, and the second one is the practice. So the principles is basically the recitations plus exam. That's what you get graded on. So that's going to be 200 points because there's 4 recitations, 200 points, 50 points apiece on recitations. So you got 200 points on the recitations, and that leaves 800 points for the exam. All right. So based on that, based on how well you perform there, you'll get a certain number of points you'll yield, and then wherever you land with a number of points will determine what your grade is going to be. Now, then the question somebody might ask is, well, what if I completely skip recitations? But then let's say that you skip recitations, but you get an 800 on the exam. Well, recitations are actually optional. All right. But you wouldn't want to do that, because if you got 800 on the exam, all you would have needed to do is to get 50 points on recitations in total, and that would give you a 5 in the course. But if you just completely skip recitations, you won't get a 5 in the course. It's just impossible. All right. But this is the scale over here, and that will land you. That'll determine what the grade is. All right. So people a lot of times will ask, are recitations mandatory? And I'll kind of pretend like I didn't hear the question, because I want you to go to recitations. I think it's a good experience. But if someone presses me on it, I have to confess, no, not really. But go to recitation. It's fun. People like recitation. I mean, I like recitation. It's much more interactive. This lecturing is kind of people can get a little tired of it. The recitation, at least, it's more interactive or more participatory. Okay, so that's the principles part, and then the practice is just the lab. So you have to finish the 3 labs. You got to get them approved by class. So the quality has to be high enough for them to get passed. You can work into groups of up to 2. So you can have a partner on the labs. But when you present to class, both of you have to be present, and both of you have to be able to answer questions, of course. Okay, so you both have to do the work, basically. All right. Based on whatever you get on the principles part, if you also pass the practice, then the grade there then becomes the overall grade for the course. All right. So that's how it works. That's how it's worked for a long time now. So it's kind of a stable system. Are there any questions on the grading policy or anything else for that matter? All right. I don't see any questions. I hope it's clear. Here is, this is the time edit schedule. So this is when we're going to meet. Where we're going to meet is on Zoom at this ID. So there we are. Let's see here if I have all these. I know that one of these I'm getting rid of. I believe it's this one, but don't quote me on that yet. It'll disappear. One of these meetings we're going to be able to skip. But otherwise, we're going to be there for all of them. Okay, then. All right. So without further ado, then, unless there's any other questions, I'm going to assume that you guys all understand the dynamics or the structure of the course and how it's going to operate. Let me just clean this up here. And with that, let's go into, maybe I'll just do it this way. Since I have it there. Hopefully this will pop up. All right. Not really what I wanted. One sec. Okay, I'm going to do this way. Okay, one sec. I just want to get this. I'm going to start it on lectures. There. All right. Sorry. It's a little bit. All right, Chrome. All right, sorry everybody. I don't really like being inefficient like this, but it is what's happening right now. But I should have done this earlier. All right. Pardon me for this delay. Okay, and now I'll go over here, downloads. And then hopefully, there we go. Sorry about that. Now I'm going to share the screen. Okay, so I'm assuming you guys can see this now. Okay. All right. So anybody just give me a hands up here so I can see that people can see this. I'm assuming they can. Good. All right. Right. So here now let's just do the introduction to the course. So what are we going to cover in this course, this 5DV202? Well, I mean, we're going to cover databases, all right? So how many people here, just a hands up, how many people have used SQL before? Anybody? Okay, good. We're getting a fair bit of people who've already used SQL. Yeah, looks like a lot of people. Good. All right. So this course is going to go, much deeper into SQL and kind of the basis in what's backing databases. One of the critical things with databases is the design of databases that we're going to focus a lot on that, because the thing is that with databases, I'm talking about relational databases here. We're not going to just cover relational databases in this course, but with the relational databases, with SQL-based databases, it's really actually it's very important how you design it. How you making those decisions about what the structure of the database is going to be are really critical decisions, and there's a lot of people that depend on those decisions being made well. So that's going to be a major focus of the course, because there's been a lot of money, life, energy wasted because of poor design decisions. So there are excuse me. There are lots of stories you can go out there and look about failed projects. We see them all the time. I mean, projects that really collapsed. And it's not always the case that it's based on the database, but a lot of times it is. A lot of times they really didn't make a very principled decision about how they were going to design the database. They didn't really anticipate how it was really going to be used. They didn't really think it through. They just kind of just gave it out to the technical people to just get this done, right? As if it was like a very routine task, but it isn't. It's actually very important task to get right? So the design of databases is going to be a big part of this course. I mean, one of the things I just want to say, one of the things that happens a lot of times I mean, I'm not sure how much if it happens that much anymore, but it used to happen a lot, was a lot of people have like a very spreadsheet understanding of how a database is. And so what they basically say is they don't really want to hear about multiple tables. They would just have this big mammoth wide table. And depending on what you're doing, that may not be good enough. Okay, that may cause a lot of problems. So having multiple tables and being able to build databases that have that is really critical. So that'll be a big focus. All right, so then we're also going to talk about database programming, or programming in quotes, kind of. It's what we're going to cover is SQL is going to be the primary one, and then we're also going to cover some side ones, XPath and XQuery. Those will those, as we'll see, those are kind of alternatives to the SQL way of doing things. So these essentially are going to fit into what's called NoSQL. It's an example of some NoSQL type technology. All right. So because this is a university and we want to kind of take a principled way of looking at things and taking kind of more mathematical way of looking at things, we're going to start out actually looking at more mathematical or kind of pure abstractions of query languages, and the two of those that are going to be the focus are going to be what's called the relational algebra, and then also what's called the tuple calculus. All right. I assume that most of you have had a logic course, right? First order logic from your logic course is closely related to tuple calculus. It's not quite the same thing, but it's closely related. So we're talking about kind of logical languages here when it comes to the tuple calculus. Also with database programming, we're going to talk about how you actually connect the database in with applications. So this is going to be the main one that historically at least was this ODBC, which is the Microsoft standard, and then JDBC, which is kind of its copy. That's ODBC was originally in C, whereas JDBC is the Java equivalent essentially. These are you always have these available. These are kind of like the kind of the ground basis of it. But we're also going to talk about it's like Python libraries that can let you connect with the database. These are a little bit easier to use, and they revolve around this notion of connections, environments, connections, and cursors. All right, so that'll be a little bit of the concepts back in that. So again, so it's going to be this issue of how you actually put a database in a actual application environment, and that's that last. This is the idea of connecting it to a host language like Python or C or Java. Okay, so all right, so let's just start out here because some of you have SQL experience. So let's just kind of start out just to kind of show a little bit of the trickiness maybe, or the nuance of SQL. All right. So a lot of people think, I mean, there's a lot of people who, well, no one really knows SQL because it's kind of a little bit fuzzy in certain areas. I mean, there's different you have different variations of SQL based on the system you're using. So like Oracle's SQL is maybe slightly different than MySQL's SQL, and slightly different than PostgreSQL. So SQL there's a lot of like little quirks at the fringes, but there's kind of the core language. Okay, so basically one question might be this. Okay, so if you look at these two queries here, select B. So we have a table there, right, with the attributes A and B, and then the three rows, one for A and 20 for B, and then 2 for A, etc. That's the table right there. So we have this one, we have the query, the first query there. Select B from R where A is less than 10 or A is greater than equal to 10. All right. So in this case here, it would be like 20, 30, 40. It's like, that's what it's going to give you back. Because selecting B is going to basically do what's called a projection to get out the B value. And then, well, does the A be less than 10 or A greater than equal to 10? Yeah, in this case it is. In this case it is. It feels like this is always true, right? That A is less than 10 or A is greater than or equal to 10, right? So then the question is this, and I asked this maybe in the chat, are these always going to give you the same result, these two queries? Always. Are they always going to give you the same result, no matter what the database is? Yeah, I'm waiting for an answer here. I mean, logically, you think they would, right? Does anybody have an answer? Yeah, it certainly looks like it. But yes, logically, yes, but I have the feeling that the answer is no. That's a good intuition. Otherwise, I would be sitting here saying, well, they are equivalent. Aha. So Oliver, good, very good. Oliver got this. Might be a null. Notice in B can be empty. Yeah, that's the same. The B can be empty. That's not really true. A might not exist. A might not exist. That's essentially right. Yeah, that's right. So what A might be is a null value, because I mean it's gonna, it's a table, so it's gonna be something there, right? I mean it can't be completely void. So there's in SQL there's a null, this kind of catch-all empty value or not applicable value. There's different meanings you can assign to this null thing, but there's this idea of a null value. So let's see here. Maybe I'll try this out right now. What are we doing for time? It's kind of a pain, because if screen share was a lot quicker, I would be much more, because here, one second. I'm gonna do it. I'm gonna use this new technology here. What is it? Screen share. Okay, share screen. It bugs. It really bugs, because I click on the share screen thing. Then it takes like, I mean, this is the reason. By the way, people say, well, what does it matter? Like later on, we'll talk about performance in database and performance in systems, right? Okay. Someone say, oh, well, what does it really matter that between like something that's sub-second, something that takes 100 milliseconds versus something that takes 1 second? I mean, what's really the difference? And it's a big difference. I mean, that's why I'm getting frustrated with Zoom here, because I click on share screen and the stupid thing takes like, 1.5, 2 seconds. And I mean, I'm getting frustrated. Sorry. I mean, maybe I should just relax. But anyways, but the thing is, it makes me not want to use it. But here, I'll do it. And then I'm going to use this brand new. This is really spiffy. Okay, I hope people can see this. Or no, they can't. Or can you guys see this? Did I just do the squiggle?
Yeah.
Good. It's this. Now, how do I do an undo? Huh. Okay, this is kind of bugs. Sorry, guys. I mean, I was using it. All right. After the break, I'll get this to work out. All right. Let's go back to here. Okay. I hit share screen. 1, 2, 3. 3 seconds. It takes 3 seconds. All right. And then 1. Okay. Now I imagine you guys can see that immediately. All right. So yes, indeed. So now if this was a null, if let's say in this 2 right here, oops. If it was a null value, then here's what SQL does. SQL is going to walk. It's going to basically look at this thing. It's going to say, all right, from R, here's R, where A is less than 10 or A is greater than this. So what it's going to do, it's going to walk and it's going to take. Now, am I going to use, is this going to match this where condition? Is A less than 10? Yes. Okay, it's an or. Okay, this whole thing is true. Therefore, I'm going to print out B. I'll print out 20. Okay, I'll go to the next one. Now, if A wound up being a null value here, then the thing is they would say, is A less than 10? All right. And the value there is unknown because it's a null value. You don't know, I mean, what it is, right? So what you get right here then as a result is you get back the value unknown. So SQL actually is a 3-valued logic. When you evaluate conditions, they either become true, false, or unknown. All right. Now, let's say A was equal to null. Let's say that we were here and A was equal to null. Is A greater than or equal to 10? Well, the answer to that is unknown. All right. So if you have unknown or unknown, what's the result of that? It's unknown. Okay. So then the whole thing becomes unknown. Therefore, if A is a null value, it is not true here. Therefore, you're not going to report the B for it. All right. However, down here in this query, if you're just going through every single value, you're just going to plop out a B for every single one of them. Okay. So if there was a null value here and then the B was the value of 66, then it would plop out a 66, right? Whereas it would not plop out a 66 here. Okay. So it's a little quirky, but this is the kind of thing that you'll learn to appreciate. Okay. So what about these? Are these the same? Okay. So what do people think here? Let's look okay. Again, if you're not following along with these right now, don't, if you're thinking, whoa, what is that? What's it? Because I'm about to talk about a join. And if you don't really understand what that means, we're going to cover it. So we're, this course does not assume that you know SQL, but I just wanted to kind of start out with this. Okay, I had a question here. So is there a null check you can do in this first example on the return? Yes. So you can basically say is or null. Okay, is null. So there's a condition called null. So you can see if something is a null value. So you could enrich this thing where you said, is A less than 10 or A greater than 10 or A is null? Then it would be, these two would be equivalent. Okay. So yeah, that could be done. I mean, you might want to say, well, then just ask this question. This is a simpler query, so why not just ask that one? Okay. All right. So what about this one here? So this again, don't worry if you're not going to follow this. It's not that hard. You'll get it later. We're going to cover it. So we're not assuming that you're supposed to know the answer to these questions right now. But anyways, this is involving what's going to be called a join. So we're taking R and we're taking S. These are two tables, and they both have an attribute named B. And in this first case, we're doing we're basically doing what's called a Cartesian product. We're doing this, we're doing a join, but we're taking R and S and we're matching them in all possible ways. And only when the B values equal each other do we print out an A. All right. That's the one way we're going to do it. And then the other one is a little different. It's basically, we're going to go through R, we're going to walk down R, and when the B value is in getting a B from S, then we're gonna print out we're gonna print out A as an answer. Okay, so these are very closely related queries. In fact, we can say that this one here, no matter what the database is, this one is going to be a subset of this one. But no matter what the database is, but then the question is is this always going to be a subset of that? And the answer is no. So later on in the course, we're going to come and get an idea why these are not equivalent queries. Okay, they're slightly different. Okay, so this one is going to actually return fewer answers. If I had the scribble board working, I would just give you a quick example to show this, but unfortunately I don't. Okay, so so some interesting now. Normally, what we're going to do is we're going to stop it right at the top of the hour. But in this case here, we're going to go over a little bit because I want to start in on some more technical stuff in the next hour. So we're going to basically go on. Normally, we're going to end it right on the hour and then start up in 15 after. But in this case, we're probably going to go to like 10 after and then start at 25 after or something like that. So I just want to finish up this lecture just for the sake of flow. So some interesting stuff about databases. Okay. So databases are, they're kind of old. They've been around for a long time. They're not, they're very useful, so they're not going anywhere. But it used to be just about like the boring stuff like employees records and bank records, etc. But now it's like, it's like covers pretty much everything on the web essentially. So a lot of your web search is being backed by some form of database. Data mining, so all this stuff about doing prediction, or doing collaborative filtering, like Netflix, right? Netflix getting the way it is able to determine what's a likely film that you might want to view. This is all being done in databases, and then of course there's the scientific and medical databases. So integrating information. So there's social networks like Facebook is backed by a database. Etc. So pretty much everything is that every application out there that has any significant data aspect to it is being represented in a database. And the question, of course, will be: is it in a SQL type database or is it in one of these no SQL type databases? That's always kind of Well, like for example, like Cambro, itself, the one we were using, that's actually in a semi-structured database. That's in MongoDB. Okay, so you can't always tell if it's relational or it's one of these document databases or semi-structured, but in that case. But of course, I mean, your bank account is most likely, I mean, I would almost guarantee your bank account is in a relational database. All right. So this is a little bit of an abstract point, but it's kind of there's a lot of interesting theory problems in databases. And one of the more interesting ones is now it's telling me that my internet connection is unstable. So I hope that we keep this going. Or maybe it's just, well, maybe it's just telling me that because we should stop at 11, but no, we're gonna go on. Are you guys still there? Did someone raise their hand so that I know that I didn't lose you? Uh-oh. Oh no. Oh, good. You're there, okay. I wouldn't want to be just talking to myself here. So, all right. So do you guys know what Turing complete means? Does anybody? Yes, but it's been pretty laggy for me. Uh-oh, that's not good. Okay. So do people know what Turing complete is? Camera lag. Okay, good. Okay, yeah, good. So, yeah, so not everybody knows what Turing complete is, but it's probably worth just kind of saying this immediately. Just what I mean, it's actually not. So basically, it comes down to this: when you have a full programming language, and it doesn't take much to get a full programming language, like in principle, like if you guys ever started with like BASIC or something, or I don't know what your very first programming language was, but you take some really impoverished programming language, you can pretty much do everything that's computable in that impoverished programming language. The simplest, the mathematical case is what's called a Turing machine, and that's kind of where the name derives from. But the idea is that basically anything that once you're given kind of a memory and you're given operations and conditions and loops and just kind of enough machinery to get going, you can pretty much compute what can be computed. Okay. Now, when it comes to query languages, though, what we'll find is that they're not quite, they can't quite do that. They're not fully Turing, what's called Turing complete. And it's a very interesting kind of theoretical thing about it is that once you decrease the expressivity of the language, you can actually do more reasoning about what its properties are. Because one of the things about Turing complete is you can't really predict whether or not it's going to halt, or some basic kind of any non-trivial aspect that, from outside, you're supposed to say, is this program ever going to stop? Well, you can't determine that for arbitrary programs coming in. That's one of the limitations of Turing complete. It's not decidable to do that. But with query languages and various fragments of query languages, you can do kind of more powerful reasoning over them. And so databases is one of these few areas, or maybe the only area, in which this kind of lack of Turing completeness in the query language is actually something we really take advantage of. So it's kind of interesting from a theoretical point of view. And it's used for this idea of query optimization, which we'll get to. So for the people who have a theoretical interest, there are some very deep theoretical questions surrounding databases. In fact, the deductive database, there was, I guess, the longest, I'm not sure if this P equals NP, how many people know about that? But one of the longest standing, and only stood for a couple of days, solutions to the problem, and then it was defeated, so it wasn't approved, was based on deductive databases. There was an attempt, as far as my understanding goes, there was an attempt that was based on some deductive database concepts. So anyway, so for those with a theoretical interest, there's a lot of deep issues inside of databases. All right, that's it. All right. Yeah, so I think I'm repeating myself here. So databases are behind everything, almost everything you do on the web. All right, so it's there. So basically, Facebook, this NSA, spying and stuff like that. All right, so then databases has an interesting concurrency control problem. So many activities, the database should be able to handle at all times. So the database is there for people to use, of course. And the issue is that we want to have multiple users. We want to have multiple users that are all, simultaneously interacting with the database and feeling as if it was just a private database for themselves. So this kind of transaction processing, we'll touch on this a little bit in the course. So that makes for a lot of interesting practical problems and also some interesting theoretical problems. So this is a kind of a dramatic example that some air traffic controller wants to book flight 123 on one particular runway for a certain period. So it's pretty important that another air traffic controller doesn't do the same thing on that same runway for a different flight, because then it could lead to problems, right? So these things, it's important to get these things kind of settled. All right, so so then we come down to like the issue of what a data model is. And actually, now that I think about it, I think that this is a good time for us to take our break. So again, we were just kind of motivation here. So we're going to get into a little bit more technical stuff. And you know, we're going to try to keep the course fairly technical, not just a lot of talking. But at this point now, this is 11:05 right now. Why don't we take our break and get back at 11:20? All right, sound good? Okay, so I'll see you guys at 11:20, and I'll stop recording at this point. So, but if people have questions they want to ask me, I'll give you a chance to do that. Let me just stop recording here somehow. Oh, let's see. I have to. Sorry, guys, I am not the best at Zoom. Stop share. Okay, and then stop recording. Okay.